Okay, we've just gone 7 o'clock, so I think it's time to start. I'll just do an introduction before we hand over to our guest speaker tonight. And to everybody on Zoom, I'm glad that you could join us for our Power Hour Tech Talk on 3D printing. I would just like to introduce our guest speaker, Pietra Rees. So a little bit about Pietra, and Pietra doesn't know that I'm going to do this right now, so I hope I don't embarrass you too much, Pietra. But Pietra is a social entrepreneur who has commercialized a few African ventures. Her new tech startup, Y Corp, provides a rich content one can 3D print straight through from any smart device to solve for localization and supply chain constraints in mining, agri-processing, and automotive industries. She is passionate about creating skills for the future using exponential technologies like AI, VR, AR, IoT, and of course 3D printing. And a lot of those activities most of us are also very keen or interested in. Pietra has been recently recognized as a winner of the Inspiring 50. She's an executive board member of the Institute of Inventors and Innovators South Africa, and an ambassador of Women in 3D Printing in Johannesburg. She specializes in growing business opportunities, integrate sustainable ventures, and she specializes in 3D printing, venturing enterprise and supply development, supply chain optimization, customer retention and acquisition, and marketing. And if you are into foreign languages, you can also ask your questions tonight in English, German, French, and Czech. So, Pietra, I'd like to now say a very warm welcome to you, and thank you for agreeing to host our Tech Talk this evening, and I'd like to hand over to you.
Thank you very much, Keith, and good evening, everyone. I'm super excited to be here tonight, and thank you for inviting me. I have really kind of dovetailed into the space of amateur radio with excitement, knowing very little about it, but I'm always interested about finding more about technology, and especially how it can link to my favorite, being 3D printing, but also with other technologies out there. So this is really exciting. I hope that I can also learn a lot tonight from any of you. So if anyone has questions or anything like that, I think that you can post it to the chat, or you can, I'm not too sure, Keith, you just guide me there when you want to have questions asked. But essentially what we've done tonight is that I prepared, talking about royal we, I prepared a presentation for you so that there are a few visuals and information that it may be easier to follow. But most importantly, I'm really looking forward to have a conversation around what you need to get out of this session as well. So it's really not just kind of death by PowerPoint, but I really would love to get into the nitty-gritty of what interests you. I'm sure that there are a lot of members that also kind of explore 3D printing. Some of you maybe more, some of you less. So I'm hoping that we can again share. So if you have any interesting information, please also feel free that if something is valuable, please do share. So let me jump straight into it, and I'm going to share my presentation. Right. So as Keith said, I love 3D printing. I am the ambassador for Women in 3D Printing in Johannesburg. It's a global organization. It's really about evangelizing 3D printing to the audience. It's not just for women. So if any of you are interested, you can also contact me. We do quarterly get-togethers, and we can share further kind of experience share. So I'm more responsible for the Johannesburg chapter, but there are some other contacts that I have in Cape and in Pretoria. So I'm more than happy, or other parts of Africa. So I'm more than happy to also put you in touch with them. But if you have specifically any of interest to explore more, please join us as well in that regard. It's absolutely free. There's no cost to it. It's really about just getting more people excited about this technology. If anybody struggles, Keith, if I can just ask you, if I get out and you can't hear me or anything like that, please shout. And I'm going to keep my phone next to me so that you can also call me. If English is leaving me, apologies. I am originally from the Czech Republic, so I might have few as my friends call it, Czechisms. And so apologies. And when I do get excited, I speak very quickly. So I try to slow myself down. But if you do have any further questions, don't hesitate. I've done this picture. I've really, I love Midjourney, and I asked Midjourney to do a amateur radio, young man in his 30s with a 3D printer next to it. I don't know what really, it came out with a lot of wires, but I laughed when I saw this picture because I, as a kind of amateur radio person, I thought that this is actually something I can imagine all of you doing, like being stuck in those pieces and having lots of wires around you. So I just thought, actually, at the end of the day, it was a bit of as a joke, at least for me, to see this space. But I'm sure it's slightly different. But I just thought to share something on Midjourney using AI and how actually artificial intelligence sees your world together with 3D printing. As you can see, some random wires sticking out of here as well. So your world is very much exciting and interesting. So let me get into 3D printing. And maybe, Keith, since you're the one right here that I can see, if you don't mind, I can pose a question here. Out of these pictures in front of you, which one do you think is not 3D printed? Let's put Keith the trick.
I would say the shoes, maybe.
All right. Yeah. No, great. Everything is 3D printed, Keith. So
wow.
Even shoes. Yeah. So that is, so welcome to the world of 3D printing. Is really one of those things that anything you can imagine can be made. Almost everything you can imagine can be made these days. You obviously need just different type of technologies, and the technologies are at different stages, but I'm going to get into it. So it's really sky's the limit. That's what I'm trying to say with this. Just a brief overview in terms of the journey in terms of 3D printing. So I'm just going to make sure that this is all completed. I just wanted to kind of paint the picture in terms of where we are with 3D printing and where we're going with 3D printing. So it's a technology that is actually quite old, if we put it this way, in terms of technologies speaking. It's really started already in the early 80s, but it was patented for 20 years. That's why it's, we've only seen really in the 2000s quite a lot of progress in that regard when the IP was actually released in the 90s and then obviously scaled. So that's why you see a lot of things started to happen in that kind of time with obviously prosthetics, with prototypes. That's where it's still obviously very prevalent. We had first cars 3D printed, houses in 2014. You probably remember this guy, since I've heard that you also can speak to the International Space Station people. I hope that they're doing well now in this time. They're stuck there. but essentially, if you can see what he's holding a wrench. And so they actually 3D printed a wrench. And if you think about it, it's a decade ago. So it's actually a long time ago when this happened, and yet it seems like actually we kind of heard about it just the other day. The other, basically, how is the technology moving now, in which direction, is that it's taking a lot of traction, not just in the automotive industry, but in the space exploration. And that's really the exciting part when it comes to 3D printing, is that thanks to these other industries like space exploration, 3D printing is essentially like there is no life on Mars without 3D printing, right? If you think about it. So that's why there's a lot of investment coming also into 3D printing because of all these adjacent industries. When people talk about what's kind of next, there is there's a study that there should be a 3D printer in every household by 2030. I think that in households in certain LSM in America, probably yes, but obviously that's different across the world. But it is getting to a point where essentially the price point is getting lower and lower in this technology, that it is accessible and is going to become a microwave. I remember I was training one of the ladies on 3D printing, and this one lady was really skeptical that she wouldn't be ever able to understand 3D printing, because she's like, technology, it's for my husband. And I said, no, and try this. And she really, she kind of got into it. And then she said to me, you know what? My mom used to take classes for microwaves, how to actually operate a microwave back in the day. And, and we actually laughed that this is kind of exactly what's happening now, is that we're taking classes a little bit how to operate 3D printing, and our kids are going to kind of a little bit laugh at us at that time later on to say, you did what? So yes, and when it comes to kind of bioprinting, so you can see this picture here at the end, when it comes to organs. So at the moment, it's still, there's a lot of progress happens, as you can see, since 20 years ago. We basically moved from printing bladder, which is obviously an easy sack, if I put it this way, in terms of an organ. And this is a miniature bladder, by the way. This is not a real size bladder, but into, having to print complex organs like a heart, we still another decade away from that. But it's coming. It's going to be here before we know it. It's already been, if you follow a little bit about the medical fraternity and what's happening there, it's just incredible progress every year. Pharmaceutical industry is obviously using 3D printing already quite extensively. But yeah, we're still far away from having like a 3D printed desktop on your kitchen counter, 3D printing organs, but we are going to get there in our lifetimes for sure. So that's just a bit of a history. In terms of where the industry is at, I think that's, I would like to just touch on that just to understand it a bit better. You obviously know this guy called Gordon Moore, and he was really talking about back in the day, it was about integrated circuits, right? And how every 18 months, the technology, when it comes to scaling, it's doubling. So what we're trying to say here is that it is impossible to predict the future, obviously, but it is possible to understand the fundamentals. And thinking about the Moore's law, we can actually translate it into an industry that we all know really well, which is the music industry. And if you think about where the industry started back in the day with a gramophone, and how it's progressed, it's really kind of taken a slower move, right, until kind of into the 80s and the 90s, and with the MP3 music, it just changed our lives completely. And what you can see is really the exponential curve that this technology, what actually happened in terms of this technology. And typically, if you look at any technology, it's going through this kind of a curve, but it's also going through a bit of we call it the valley kind of despair. And that's a little bit where the 3D printing also encountered itself to be in. And I'll just show you what I mean by that. Right. So essentially, again, when it comes to revenue and the markets, where we at the moment and where we're going, it's that today we're looking at about this industry being $18 billion in terms of revenue. It's mainly moved from that kind of your prototyping, making, molds, again, very much in that engineering prototyping space, into end user products. And that's really where it's taken now over the last years a huge ride forward because of that end user product, and also of the other industries that I already mentioned, like, for example, space technology, robotics. We can't think robotics without 3D printing. They are 3D printing a rocket to get to Mars so that they can so that it can 3D print a rocket to get back to Earth. So, so that's essentially what's happening. And we kind of predicting that by 2030, the predictions are that the industry should reach about $180 billion in terms of revenue. So in the next 6 years, if you think about it, it's going 40% year on year. And we can already see the big jumps kind of happening. So really that exponential curve that I was indicating or alluding to in my previous slide, you can see that the industry is following as well. So it's kind of in its early stages, but really going to shoot up fairly quickly because of all these other kind of elements that are happening. And I'm going to add to that a little bit more onto these drivers in this slide. So essentially, we have the technology drivers, right, and the demand drivers. So in terms of the technology, we really have to, and I'm going to get to that as well a little bit later, think about 3 things when it comes to 3D printing: the printers, the technology itself, the AI, the software, the design, and the materials. And then the drivers in terms of what's driving these technology aspects is really time to market. So everybody is obviously expecting things to happen really quickly these days. So if you think about molds, in terms of when we needed to have casts and have a really difficult way how to CNC a machine certain parts, and now you can 3D print them in a much faster time. It's a game changer. Hyper customization, it's massive obviously in a lot of industries, but mainly this is really the automotive industry as well, where it's the small batch manufacturing, organic manufacturing, and superior performance products. It's all linking to a lot in the automotive space. We can also see it in, as I mentioned earlier, in the other industries like clothing, shoes. Everybody wants to have customization to fit their own bodies. I always I love this example. There's a Dutch company that actually 3D prints bras for women. And it's just because obviously different shapes mean different things, and you can't just assume that one kind of cup size fit all and everybody has the same cup size. So it's really weird now talking to men about this, but I just wanted to understand the hyper customization that is actually happening in the market, that is really going anywhere from making shoes, underwear, to making technical products. I probably blushed completely right now. I'm not too sure now if we can actually release it on YouTube, Keith. Just joking. And then small batch manufacturing, this is something that I love and I'm really passionate about how it can change Africa. Huge opportunity because it's the world doesn't have, when I'm talking about the world, I'm talking the Northern Hemisphere, more the developed world, in a sense of the markets there. They don't have the same problem that we face in Africa, right? You all know they experienced it to a degree thanks to COVID, but we experiencing all the time the time to deliver the products, right? You sometimes wait 6 months, and you would know it. It's sometimes parts for your car that your kind of mechanic tells you, guys, we're waiting for the part. It should be here in 3 months' time. So it's those kind of things. So and also the infrastructure. So in the mining space and even in the agri space, the infrastructure is not there simply to just quickly deliver the product. So in Europe, when you talk about parts and spare parts, they're kind of looking at you like, so what's your problem? We can get it almost like the next day. Yeah, so we can't. And that's why this whole small batch manufacturing opportunity is huge in Africa. But because we don't have necessarily the massive investments that would be attracted typically in the Northern Hemisphere, we don't really see it scaling as much as we should. But this opportunity, and I'm going to touch on it a little bit later as well, is incredible. But yeah, and I think that today what we also need to acknowledge is that thanks to 3D printing, we're actually getting superior performance in terms of the products. In a number of cases, especially in the automotive industry, you will see some of the detail. It's actually incredible. A lot of these luxury customized cars You know, they sometimes remove, I mean, Tesla does it all the time. They removed, you know, something like sometimes 10, sometimes even 100 pieces, and they turn it into one because they were able to design with the help of AI to really ensure that when you take into consideration the materials and the material science together with AI that can compute in terms of what's possible in the design world, you get incredible new organic designs that were never possible before. And you can't machine them, by the way. You can only 3D print it. So that's why this is actually going to even go further. So in that, I just wanted to touch earlier on what's been happening in this industry and why we haven't seen perhaps faster growth, is that this is typically what happens in a technology in early stages. And my kind of prediction is that's what we're going to be seeing now with AI as well, is that you have a huge hyper curve going up. So everybody is crazy about this for this technology. Everybody is saying this is going to change the world. And then you start seeing that kind of, which we call the trough of disillusionment, where people are actually saying, you know what, it's not really what we had in mind. And that's for all different reasons, right? Because the technology is not at that level, perhaps, you know, that people were hoping to be. Because obviously technology needs to evolve. You need, you know, different components. You get better components, better raw materials, and etc. And then it's really kind of once you get through that dip, if I put it this way, you can start actually seeing the growth again. And that's really the exponential growth. So what we've seen really in the 3D printing is that in the 2000s, it's really up until about 2014, 15, it was going like this. Then we saw this dip. And now it's picking up again from the time of, again, thanks to COVID, I can actually this time say positively, because people realized the disruption in supply chains, people invested more into this technology, and now it's actually scaling up again. So, and you'll probably see the same is going to happen with AI. So there will be that dip, everybody invested now, and then we will see that growth again, just FYI, if anybody's interested in this. So I've already mentioned that there is this prediction that by 2030, there should be a 3D printer in every home. The secret sauce is really kind of about these three components, is the technology, materials, and design. So they all go hand in hand, and it's really, one needs to understand all three to get the best out of 3D printing. The type of technology that you probably came across is, I call it, make it easier for everyone, a printer that prints plastic that you've probably seen before. It's the FDM, is a fusion deposition modeling type of 3D printing. Then it's typically a carbon fiber printers that some of you might have come across. The lucky ones, the titanium printers, platinum printers, these are really kind of in the labs of some of the big universities, as you can imagine, and CSIR. There's also a porcelain printer, wood printer, construction printer. I mean, there's just a taste of what's there. But I just wanted to kind of demonstrate the vast kind of opportunities and the industries where actually the 3D printing is already happening. The type of the most popular technology for people like yourselves is really in the FDM, as I mentioned, the fusion deposition modeling space, which is that kind of melting and creating those layers. Most popular printers for schools and homes. Probably some of you may already have one. The other type of printers is stereolithography, which is also very popular. What it does, it uses UV laser beam to really harden the resin to get the shape, also obviously in layers. And I'm going to unpack which ones kind of to look at and start with. And the kind of the third most popular one that you should pay attention to is laser sintering. There's obviously others. There's much more, more in terms of printing, 3D printing that is available, but really kind of for your interest, the space that you're in, I would suggest really focus your time on those kind of printers because firstly, they're accessible. And you I doubt that somebody would just quickly tonight jump on a 10 million rand opportunity to get a 3D printer. So I'm just getting really to the ones that I believe that you should keep an eye on. And I'm going to also show. So this is the FDM printer. You can see this is obviously speeded up, and you can see the layers obviously being created by this printer. So this is your classic FDM printer. This is your stereolithography. As I mentioned, that's the resin that is hardened by using UV light as well. So what it really happens, it creates those layers. It's a little bit harder to work with, just because I personally had one. I sold it because I just wasn't necessarily the person who enjoyed the chemical reactions and the curing stations, and I ran out of patience, I'll be honest with you. And my focus was not necessarily to have the absolutely perfect detail. This type of printing is brilliant and you can see the quality and the detail that you can get. Printers start from about 5,000-10,000 rand onwards, depending on the brand. But so they are very accessible. By the way, the FDM printer, I have some more slides on that. You can get into it for 4,000 rand, but I'm going to get to it a little bit later. This is I don't know if you can hear, but even if you don't, that's
So the
fine.
first step of our additive manufacturing process is 3D design. Our designer will either create a new design from scratch or take an existing design and improve it, add features that take advantage of 3D printing. We now have the capability of modeling our processes. So we can take these virtual designs and simulate our process in the computer, verify the designs are going to work as intended. So once we validate our 3D design, we will start by printing that in plastic. This is a relatively quick and inexpensive process that allows us to give us an actual 3D part versus a virtual design. We're in our additive manufacturing lab in Indianapolis, Indiana, next door to our powder facility where we make the atomized powders used in 3D printing. This printer has a 400-watt laser. A doctor blade carries the powder across the build plate. The laser then goes down and selectively melts or sinters the particles together to form a solid part. And then this process just builds layer by layer. A key advantage of additive manufacturing is the reduction in raw materials needed to process a part, because only the powder that's needed for the design is used. The remaining powder is captured. And working with our powder facility, we can actually recertify these powders as needed for different industries. Once we have printed a part, either in plastic or more importantly in metal, we can scan the part and measure the dimensions and validate that we've met the criteria of our design. Additive manufacturing allows for complex parts that cannot be manufactured by traditional machining. This allows our customers to be very innovative. They can create designs that weren't possible in the past, and this can lead to improvements in efficiency, cost, and performance.
Right. So I think that is so if you once essentially you're progressing on your 3D printing journey, this is something where obviously one would love to get to, where you can use laser sintering, using powders, metal powders. It is fairly expensive to get into the game, but the printers are getting cheaper and cheaper. The last time I looked at a relatively a 3D printer that could do that, it is in a few million rands. But it's as I mentioned, it is getting cheaper and cheaper. But what's important is that essentially what you can start getting in those samples is that, for example, so this is a miniature of a manifold, right? But what it was discussed in the video is that you can start seeing how those parts would essentially look like. So you can start printing prototypes, you can start studying it, seeing whether it has the kind of relevant shapes, properties, and etc. that you require before you start than investing in having it printed. By the way, there are several 3D printing houses in South Africa. One of them, for example, Mentors, that you might have come across before, where you can get parts printed on demand. So they have great nylon facility, great HP machines, 3D printing machines, where you can actually get amazing parts printed in nylon that really last, that have great properties. So it's one of those things that you don't necessarily need to obviously own an expensive machine. You can get it still 3D printed with the right technology. But I think the key is, you know, how do we get into 3D printing and use it in such a way that it can help you in your process in terms of what you want to achieve. When it comes to materials, we really, and I'm going to stay in the realm of the FDM, which is the fusion deposition modeling, which is the plastic printer that you've seen earlier. The reason for it is that I think that it's one of the best printers to start with. It's printers that would be suitable for what you want to do in your space, in the amateur radio space, because you can obviously, it gives you an opportunity to really print some of the items that you need without necessarily investing heavy into some more complex machines. So I'm going to spend a bit of time on the materials that you need to be working with, or you want to be working with when you have a 3D printer. So to start with, typically where people start is a PLA. So PLA is what we call polylactic acid, is the easiest to print with. Literally, my kids already from the age of 5, 6 been using PLA and printing in with PLA. It's super easy. You can get some simple prints done for what you're looking for. You know, anything that goes inside of your maybe storage, garage, workshop. So it's great to start with those, whether you need sorting boxes. You know, I've headphone stands. I have so many things that, you know, obviously kids they always end up printing all sorts of toys, signage, you know, or for example, you want to start printing some of the stuff. So this is our prototype before we actually went to print it in the nylon expensive machine that I mentioned earlier. So you want to get all your kind of goodies done using, for example, PLA, and that go inside of your house. Then the next material that you want to explore is the PETG. Now, this is something that is super useful in your space because it is UV resistant. So PLA, in theory, should biodegrade under the right condition. I'm not talking, so PLA biodegrades under the right condition. So you need the right humidity, the right, obviously, ingredients, and etc. If you just dump it somewhere, it will take 100 years for it to die, to just disappear. But what it does, it's made typically out of starch, you know, for example. So what it does, it warps and it absorbs a lot of moisture as well. So it's not durable. That's why. So if you, for example, and I just printed, if you can see it, a little knob for a radio. So things like that perhaps, you know, goes into a piece. You can print in a PLA because this is maybe, you know, inside of your house. But if you need something that is going outside, so when we're talking about antennas or any other housing that you need to have, you know, being in the UV light, you want to use PETG. It also, what's the benefit of PETG? It also is more durable. So it's not as brittle as PLA. So for example, this is a bracket that we use actually in a car, one of those elements that couldn't be imported in time. So, and that's actually done in PETG. So in your space, you want to really work with PLA and PETG most of the time for the items and elements that you're probably looking for to print. The other is ABS. ABS is typically what you know from Lego. So this is what Lego is made out of. But so ABS is much harder than PETG. It's difficult. It's more difficult to 3D print with it. You need a enclosed environment, but it's brilliant when it comes to, you can machine it. You can, again, you know, it's more durable, so it won't break as much as, for example, PETG. And however, again, I was just thinking, in your space, you also need to consider flammability, flames, fire. So one of those things to take to consider is that you know, if it's anything that you worry about that it can catch on fire, you don't want to use PLA for sure. But PETG is actually better. What it does is that it's not completely, obviously, fire retardant, but the flames, it should, in theory, almost put the flames down. It won't not continue burning. I think that's what I'm trying to say here. So really looking at it, PETG is one of the materials that you do want to use in your space specifically. Then there's also the flexible materials, which are awesome. Lots of fun. We've been doing, for example, seals. So it's really, you can see it's super flexible. It's you can bend it. Properties are amazing. There are different types of flexible materials. We love using, for example, PEB, PEBA. There are different manufacturers, so you need to really get to understand the materials a little bit better, but I can also exchange notes around that in terms of the flexible materials, which suppliers, for example, are great to look at. And then there are others. The one I would like to just touch on is HIPS. It's really, when you start looking at dissolving. So let's say you print a part in ABS and other parts you can print in HIPS, for example, supports, and then you essentially put your component in liquid. I mean, in the right liquid, and it dissolves. So the HIPS would then dissolve, and you have a perfect end product without machining it or needing to change, you know, needing to spend a lot of times in post-production. So that's kind of another element that you should be aware of if you want to print a little bit more complex parts. So, and that's what I wanted to say, why complex parts is that if you're looking at metal, or, you know, even if you're trying to machine, as I mentioned earlier, if you want to use, for example, ABS together with HIPS, you can start getting into interesting area when it comes to design, right? These are obviously metal parts, but you can see it's impossible to do that on a CNC machine. You will never be able to do a hole within a hole within a hole within a hole. So this is really just possible thanks to 3D printing. This is what these two pictures on top is what I was talking about when it comes to the automotive industry, is that this is what you see is the classic, you know, metal part that would be used traditionally through subtractive manufacturing. And this is really the beautiful, you can see the organic design where, you know, with the help of AI, you can actually get the most incredible design structures. And even if you look at the thin tiny pieces, but because of the structure, it's really withstand the pressure that you need, you know, and combined, for example, with the right density and etc. So whether you're using titanium parts and so forth, it can only be done through 3D printing and using the right software with it. So that's why it's such an exciting space in the automotive industry. You know, Tesla is now, for example, printing, you know, they're not just using it for molds. So for example, back in the day, it would, you know, that you would need I think back in the day, they were using actually a wax mold when they were making cars. And then, you know, then they were obviously metal molds. And now with 3D printing, you know, you can really decrease it from, they're decreasing now from 97% to 4%, the costs and of making molds using 3D printing, and also the amount of parts. They have less parts because you can combine the parts together. So instead of, if you think about printing making 1, 2, 3, 4, and then putting it together in a piece, you can actually have all of that in one, because of that design element. So So that's really why the technology is going to get more and more used in the aerospace and in the automotive industry, and replacing really those parts one by one. We've seen it even in the mining space. You know, one of the mines where we're looking at replacing a part that was actually getting into, there was a housing, and then the part was attached to it, and then we were looking at they wanted to replace, obviously they were constantly replacing that part. And then when and they actually approached us to say, can we actually 3D print that? Great, and so forth. But then when we actually look at it, we actually said to them, can we actually 3D print the whole piece with the housing? Because then in that case, if you do it as one, you won't have that wear and tear, right, on that piece and breakage. So actually sometimes 3D printing it together, you get a much better endurance, if that makes sense, on that product. You know, when we talk about 3D printing in general, we also will touch on different spaces. I mean, school is another thing where you will find 3D printing being used a lot in robotics. As I mentioned, design, architecture. That space is growing like crazy because of construction and 3D printing into construction. So just wanted to touch, because there's a lot, often these questions are asked, you know, how is the 3D printing in construction going? So if you don't mind, I'm just going to entertain you a bit on that. So I've kind of chosen a few companies, top 3 companies in the US and really in the world, and then one company that does 3D printing in Africa called 14 Trees. So what's interesting about them, so these are really the pictures 1, 2, 3. So this is one, the house on top is a 3D printing house by Icon. This is the second one, is the tallest Guinness Book record 3D printed house. It's actually an office, municipality office in Dubai. And it's a 2-story building done by Episcore. And then you have SQ4D. They also are one of the first to 3D print houses for sales and with certified occupancy. The ones in mainly in East Africa, Kenya, Malawi, is done by 14 Trees. This is one of the examples of schools, as you can imagine, is going to change mainly the local housing space. There's a lot of debate why we don't see more 3D printing in construction in South Africa. I'm not going to get into that. There's a lot that goes with it, whether it's certification, it has to do as well with take to market. Things takes time. You know, people prefer different things. Awareness and education to make people move away from brick and mortar that they know to a different type of materials takes time. Takes education, takes awareness, all of these things. So one really, not just the certification. So it really, all of these aspects go hand in hand. But if you think about it on the earlier slides that I mentioned, that you can 3D print kind of one house per week at about $30,000, that's pretty good. And that's, as you will imagine, it will continue going down in terms of the price. What's really happening is that the construction industry, you either have robotic arms that obviously making the layers, which you might have seen in videos. So which typically like an Episcore, they do that really well. And then 14 Trees, they use a gun tree. So you can go as far as that gun tree space, you know, whereas with the robotic arm, you can make it as big as you want. You can go anywhere with that robotic arm. And again, what's also important to note with this space is there's a huge opportunity around materials. So I always say, you know, kids nowadays, anything around material science is going to be huge in where we're going with this, because, you know, different types of machine would need different types of materials. And if you think about even 3D printing, what you can print with, so this is typically like a cement, right? But now think about the composition that you can make. You can think about adding recycled material. You can crush recycled cement, you know, maybe reuse it. So there's just such a huge variety that this is just, we just seen the beginning of it. And from what I understand, is that in Dubai, they want to, by 2030, they want to have 30%, if I'm not mistaken, of their houses 3D printed. So Dubai, because obviously the situation is slightly different, because obviously they're struggling with labor. It's hot in these spaces, so you really can't have people in 50, 70 degrees Celsius too much in the construction side. But yeah, essentially this is so 25% of all building by 2030, they want to have 3D printed. So it's a big move in this space, especially in the Middle East. So local supply chain, I already touched on this. It's again big opportunities in that space. As I mentioned, something, you know, you can repurpose things, you can get things to last longer. We had a great example of some of the items, like for example, impellers that lasted way longer than the original part. And we were actually laughing with one of our engineering partners when actually the client was saying, you guys need to make it in such a way that it actually breaks. Otherwise, you will never make money. So we were really having a good laugh. So that's kind of the space. You again, I just in terms of time, so I don't want to get into every little detail of it. Local innovation, this is just a touch on. You would know that this is kind of a tractor that you might have seen, not just in South Africa, but anywhere in Africa. You can repurpose things. What I'm trying to say here is now, thanks to 3D printing, you can get these machines to push their lifespan and go a little bit longer. Healthcare is massive. They're already 3D printing. Obviously, upper arm prosthetics, we 3D printed on our small printer, one of just for the school environment, this hand. And it took from a cost point of view, it was 200 Rand. And it took a day and a half. So it's what's happening in the space is, again, we at the precipice of what's possible. Just the 5 big disruptors, I'm just going to touch on them quickly. So it's accelerated product life cycles. As I mentioned, people want things tomorrow so that you can increase the turnaround time. You can get new manufacturing strategies footprint. So this is, for example, one of the 3D printed cars. And I imagine you can have a model that can be 3D printed anywhere. So you can design it in Johannesburg or anywhere else in South Africa. And then somebody in Malawi can 3D print it, having a machine. Shifting sources of profits. This is the shoes keys that we are talking about. So Adidas, for example, the customized, but you know, when they started, they, for example, had 5,000 shoes, which is commercially not possible to make through traditional manufacturing in order to make any money, you know, with the right molds and all of these things. But with 3D printing, you can. And that has its limitation at the same time, because, you know, you can really, the units are much smaller, on a much smaller scale than, that's why the customization actually works as well. So it's an upside and a downside. New capabilities I already mentioned, for example, medical space, latest design. So CAT wants to 3D print 10% of their parts by 2025. I think they're a little bit further than that. It's happening in the basements in America, but I think that there is a lot for that, is that a lot of OEMs are looking at manufacturing some of the, especially aftermarket parts through using a 3D printer. So really, this is where I would like to just kind of get a little bit more practical. So I just pulled out a few kind of images that probably may look familiar to you. Some of them were not, I didn't know what they were, I won't lie. But I know that you would probably smile when you see them. So these are all free models that are available online that you can find today, and you can 3D print if you have a printer. There are some others. These are the different knobs. I think I 3D printed this one. Can't remember which one it was there. Casings, all of these things that you can think about. So these are really a lot of, you can see a lot of are free. There are some that might be at a cost, but again, as you can see, 12 Rand, if you really want that model, that specific knob, it's not bad. So it's really the cost of design is expensive, but because of people like you who are enthusiastic about certain stuff and you want to share, a lot of actually people design things and they put it online, and you will typically find them on things like Thingiverse and, you know, My Manufactory and etc., where all of these actually already designs are for free. The printers. So when people ask me, where do you start? The one in South Africa that you typically probably might have come across, and somebody might already own it on this call, is Creality. Ender. People say, okay, do you have an Ender? It's a great entry-level 3D printer. You're probably looking at 4,000 odd rand to get into the space. And it really does its trick. It prints with PLA, as I mentioned. For anyone who wants to start, it's a 4,000 rand investment, but you can really get into the game and understand what, you know, starting printing with PLA, as I mentioned, all of these items that you saw here, you can 3D print. However, that's the challenge, is that if you now want to print items that will be outside in the garden. So if I go back here and if I start thinking about antennas, if I even start thinking about casing and etc., I would like to have something that won't warp. So then I need to start printing with PETG. Creality, you will be pushing it in if you want to use PETG because of the properties of PETG. PETG melts at a high temperature. It's really ideal. It likes it at 260 upwards, between 260 to 80 degrees. So you need the right essentially nozzle that can heat up, you know, with the extruder to reach that temperature. And then you want the bed, which is obviously the bed where it prints, to also reach certain temperature. Again, a PETG kind of likes it at about 70, 80 degrees. And again, you will be pushing it with this printer to get there. So if it doesn't stick on the bed, it won't print. It just will become loose and it will never make it. So I kind of put together a few other options that you can have a look at, where you can start printing with PETG, and some of the resin printers, what you have currently in the market. So Creality also has obviously more advanced printers, not just the Ender at 4,000 Rand, but as you can see, those printers are starting to move. So you're looking at doubling it. So from 8,000 Rand, you essentially get access to a much better quality printer where you can start with printing with PETG. You can leave it outside. I mean, you know, when we start talking about door handles, markers, I've all sorts of stuff here. When you start obviously being in that space, you know, you kind of looking at that. The one printer that's been changing the game now is Bamboo Lab. It's a wonderful printer. There are a lot of Chinese, as you can imagine, they got onto this thing very quickly, and they repurposed it. And you have some of the copycats, and one of them is, for example, the Flashful Adventurer 5M and the 5M Pro. I'm actually having one behind me as well. There are great printers. You know, you can find them at different prices and in the market, but just to give you a bit of an overview in terms of where you want to be. Right, I don't want to spend too much. I would rather like to ask a few questions, if that's okay, Keith, from anyone, because I can talk forever.
No, thank you, Pietra. You've really given us a good overview of the industry, and I can see your passion coming through as well for 3D printing, and I've learned a few things that I didn't know tonight. So the chat is available and the questions are open, guys. So if you would like to just unmute and ask a question or raise your hand to Pietra, please, now is your opportunity. Go ahead.
Quick question. So I own a Creality Ender 3 version 2.
Okay.
And it's right now going to 5 years old. And quick question, would it be beneficial to replace the Kapton tape or replace the hot end entirely?
So I personally don't have necessarily that much experience with an ender, but you're looking, you need to, so really, sometimes you can just replace them. In some printers, it's just the nozzle piece that obviously, in terms of as it goes into the extruder, that you can replace. Sometimes you just need that piece. Sometimes you just really need to make sure that the whole extruder can heat up to that temperature. And as I said, with the enders, I am not sure if you can actually get it to 260 to 270 degrees. That's the only thing. So I know that people tinker a lot and they upgrade enders to machines that are totally different to what the ender was at the beginning. So you can probably find all sorts of ways of how to replace pieces on ender online from different machines. So I would just suggest, if you want to do it, upgrade it, because it's worth it.
Awesome. Thank you so much.
Thank you, Nathan. Henry, please go ahead. Henry, ZS6IIX.
Hi, good evening to everybody. Yeah, sorry, I own 3 printers at this stage. I started with Creality CR6 SE. Then I went to an Ender 3 S1 Plus, and the latest one is a K1 Max. Now, what I found is all 3 printers run 24/7. What I found is if I print something for RF, I got a problem when I'm using PG and PLA. I had to move to ASA or to ABS because of the velocity factor and the density factor of the material. As soon as you put RF through it, it changes the characteristics of the whole system.
Yeah.
And you have to calculate it for that. So if you use something for RF, I would suggest to use ASA or ABS. If you can afford nylon, quite expensive, but very, very good material. You said Battle Pet G on Bed Slinger. Now, Bed Slinger is the normal FDM printers. You can upgrade your print head and the Biden tube inside your hard end, and you will be able to print that. If you move from the normal Bowden tube to maybe something like a Teflon tube, you will be able to. And Nathan, if you want to upgrade your Ender 3, you have to replace your main board and your hard end to be able to do that. That's my contribution. Thank you.
Thank you very much, Henry. You've obviously got some experience in this game as well. Nigel, ZS6RN, please go ahead.
Good evening, and thank you, Petra, for a very informative overview of the 3D printing. There are lots of aspects which I was completely oblivious to, as I'm sure others were as well. So very enlightening, and very different presentation, by the way, Keith, to what I was imagining. I thought it was going to be more, not that I wanted it to be, but a practical, okay, these are the mistakes you can make, this is what you can do, don't do this, and so on and so forth. But nevertheless, it was still a very interesting, at least for me, and I hope for everybody else as well, an interesting presentation. I have a confession to make. My 3D printer is still in the box it was delivered in about 2.5 years ago. So I'm not going to say any more on that. But what I do have is for you a couple of questions, Petra. The merits or not of having dual extruders from a hobbyist perspective, or from our particular usage as amateur radio operators and the bits and pieces that we want to make, and maybe some other things as well. And on that point, let me just say that the first item that decided that I should actually get a 3D printer, I have an item that most of, I won't give my age away either, but the product is a Workmate, a Black & Decker Workmate. And on Black & Decker Workmates, there is a known problem with little clips that hold the legs in. And they are really ankle smashers. They will scar your legs for life if you have a Workmate with broken clips. And they break with regularity. And you can't buy them in South Africa. And I've tried rubber bands and magnets and all sorts. I thought, there's so many things I can use a 3D printer for. and I found a free design for Black & Decker Workmate clips. That's why I initially bought it. But since then, I've had lots of other things that I would like to do. And my question to you is the benefits or not of having 2 extruders versus 1. Is it really going to make a difference from my hobbyist point of view? And I'll just give you all 3 questions or 2 questions, and that way you can summarize it up and tell me what's what. And the second thing is using a 3D printer to make printed circuit boards. And by making printed circuit boards, what I'm thinking is that if you lay down a layer of plastic onto a PC board laminate, and then you will etch that as you would have done with a photoresist or other process. And I'm thinking, well, I could try it, but with you coming on this evening, why must I reinvent the wheel? I'll just ask you. So let me leave it at 2 questions. 2 extruders versus 1, and using the 3D printer to make printed circuit boards, or at least part of the process. Thank you.
No, thank you so much, Nigel. So the problem is that I ran out of time. I just wanted to get a bit of a more sense in terms of where the 3D printing industry is at. And then I realized that I was running time out of Princeton, but I do still have some time, so we can discuss a few practical things as well on that. So just to answer a few of your questions. So firstly, around the dual extruders. So I've personally used, so we have what you call Create 3. We it's one of the Fleshwell brand. I personally like them a lot, just because also the aftermarket warranties and stuff like that. But we've really used them only for automotive parts mainly, and that's because of the dual extruder. As I mentioned, the 2 type of materials that you can print with at the same time. And then, as I mentioned, you can, for example, dissolve the supports. So then you don't need to necessarily machine it. To be honest with you, for a hobbyist, from my point of view, I think it's an overkill. It's like using a fire hose to, to water a little pot plant to start with. So just an absolute honest truth on that. But because if you just in the space of, hobby, and the little that I have experienced so far in the amateur radio space, what you want to try to print, obviously, if you need to start, and I think that's what we discussed earlier, if you have SBS and ABS, so those are really good materials that you want to be printing with, and they can be used together with the dissolvable materials. But equally, one can look at, well, can't I just use ABS and print it with the supports, and then essentially, because ABS you can then post-product, you can use the post-production quite nicely, but you might not get inside of, as I said, of a hole to take a support out. That's why you would like to actually use the dissolvable liquid to essentially for that post-production. So it really depends what you want to print, but I think it's just a long answer. But I think the dual extruder, because typically a dual extruder benefits, it's not just, I want to have a pretty print to have, but it's for the benefit of the different materials being printed together, right? So you might want to print something with flexible materials part, for your design. But in the hobby space, it would be a bit of an overkill. And I forgot the other question. So I'm giving my age away.
Making, no, you're not. Printed circuit boards. There are several ways. And the third question, which is related to the circuit boards, was if I were to make a printed circuit board using a conductive material. Yes. But I don't know how conductive that material is and whether I could do that with an FDM printer. So yes, you can.
Yeah. So you can. I think, Nigel, very short answer is that if you can use, and we've done it before, we actually, some of our customers are electricians, and that's what they do. So they're using FDM printers. I obviously wouldn't suggest you need to use enclosed with fans. You need to regulate the temperature. So you can't necessarily use a entry-level machine for that, but you can. Absolutely, a straightforward answer. If somebody has look, for example, the Adventure 5 and Pro, just not to give, but anything starting from about 12,000 and onwards, machines from the market is a good now. It used to be anything from 30. Now it's halved, the price halved over the last year because of the new, also because of Bamboo Labs and etc. coming out. The technology progressed dramatically. So really from 12, 15,000 Rand, you can get good machines that I wouldn't dare. So for example, we used the Fun Mat, which was one of the first kind of enclosed, 120,000 Rand machine. I'm doing the same on Adventure 5 and Pro, what I used to do on a Fun Mat. Unbelievable what you can do. So yeah, absolutely. And the third question?
That was the material to use for making the etch layer.
Yeah.
Yes. No, not the conductive one. The step before, if you use photoresist, or no, you can use photoresist, or you can make a template that and apply that to the copper board, which the etchant, ferric chloride or some other material, is going to not remove the copper. And I was thinking of making a printed circuit board by putting down the plastic onto the copper board, sticking it in the etching tank. There, the ferric sulfate will etch away the copper that is not covered, then remove the plastic, and you've got the printed circuit board. But I don't know. And I thought, you're here, let me ask. Otherwise, I'll have to try it and see. And that's my lot for tonight.
Thank you so much. I must be honest with you, when it comes to using, copper and etc., I typically use one of our engineers for that. I can get back to you. I can connect you with them. He's amazing. If somebody has from the audience answer to this, I'm more than welcome to give somebody more experience in the space to talk.
Thank you.
Thank you,
Nigel. Then let's move to Richard. Go ahead. ZR6 Delta Echo.
Sorry, I just lost my place there. Evening, Petra. Thank you very much. That was fantastic. Really interesting. I've got a couple of questions as well, so I'll be quick. You showed a picture of a wooden part that was 3D printed. I could not believe that. Can you just tell us a little bit more about that? And also, I wondered if it's possible to print chocolate in the food space, being a bit of a chocoholic myself. But my real question is, the 3D prints I've seen up until now, most of them are a bit disappointing in terms of the resolution of the layers. You can clearly see that they are 3D printed. And I'm just wondering if that is because it's an older model printer, possibly a cheaper printer with a lower quality nozzle, or if it comes down to more to settings and design, and perhaps a bit of experience on the side of the operator. Thanks very much, Petra.
I love that, Keith. I just love how everybody's answering kind of their own questions. So firstly, so yeah, food printing is big. It is already, because it's customized. I mean, they print chocolate print. You can actually buy chocolate printers today. I think it's still overpriced. And unless you are really upper class bakery that needs to customize certain parts of chocolate cakes and cake toppers and stuff like that, otherwise it would be a bit of a waste of money at the moment. I would wait a few more years. Again, the price of the technology is going down as we speak. So if you are chocolate, it's coming. But yeah, it's coming, and but in the next couple of years, you will see more of those printers in a coffee shop, even, where you might be buying your favorite cappuccino. So that's one. Just in terms of the wooden printer, I'm actually printing with wood-like filaments. It's actually infused PLA. So the polylactic acid that I was talking about, it's infused with wooden parts, and you can really print different type of wood-like products. So on your entry-level machines that are a little bit of a better quality, not just some entry-level second-hand one that is old, I would suggest use a little bit the ones that are kind of the last couple of years that came out. You can print with wood infused PLA anytime. The only reason why I'm saying lately is that the technology is there, it's not that, but it really eats your nozzles. It eats a lot of, because of the splinters, as you can imagine, it's quite rough. So, you know, anything that is infused starts a little bit wear and tear more on your printer. So when you do print with the likes of wood-like filament, for example, just make sure that you have an extra nozzle handy. You would need that. And but yeah, on those you can go ahead and print it tomorrow on your friend's machine. And when it comes to resolution, so you are 100% right. It's all that you mentioned. As I said, you answered your own question. So we, for example, use a much smaller nozzle. Typically one would use, you know, 0.4 millimeters. You can really go down. You can use 0.3. You can already seeing that the layers are much smaller. You can slow down the print, you know, again, so that all of these things, and of course, quality of the design, all of these things come in play. And obviously the newer the machine, the better it is. But even the ones that we've seen, the replicas of Bamboo Labs, you know, they print, yeah, you know, you can print very quickly. That's the whole thing about this new technology is the speed. But to get the quality, you still need to slow it down to the normal, you know, kind of 60 millimeters per second that we all used to. So that's just as FYI, but obviously the younger the printer, if I put it this way, the better quality you're going to get. And just as a last kind of point on this, I always say, get into it. For those who obviously, I know that there are some people that have been having a 3D printer already, having a few working 24/7, and that's, I love that. I mean, you can see that it's working. But for those, just get into it. I would suggest not too sure about secondhand printers, because you might get frustrated, and you know, you actually spend a lot of money on maintenance before you know it, because the technology, the wear and tear is visible in the space. But just start, get yourself even that Ender. It's a great machine to start with. If you want to, you know, get a little bit further quicker and not get frustrated within a month's time, to say, okay, that's great. Now I would like to move to PETG and you know, other type of materials that we spoke about, then I would suggest start investing, double it from 8,000 Rand, and you're in the market. You know, my kids paid for their own 3D printers because they went to market selling all sorts of stuff. I mean, it's you can really make the money by very quickly on that printer, selling your own designs or somebody else's. So I'm almost for that person. Get into it for sure if you don't have the budget, but if you can, and if you can capitalize, because you know you can perhaps generate that income from that printer, just start at that. You know, get a little bit of a better one at that 8,000 Rand onwards that can print easily with PETG, unless you love tinkering and you want to redo a printer that we discussed and make a completely new printer out of it.
Yeah, thank you, Richard, for that. Are there any more questions?
I got one question I'd like to ask. Okay. Oh yeah. So with the G-code files, the encodings you can use are either ASCII and binary. So which encoding would be best for the optimal accuracy of the model and the finished print, and as well as the detail of the finished print?
So are you talking about the slicing software? So I just missed the beginning. Are you talking about, are you using Cura in terms of the?
So I use two. So I use Cura, and then I would also use
So Prusa has a great
Pausa.
Prusa, yeah. So Prusa is depends. Some people prefer Prusa to others. I'm a big Prusa fan because it's from Czech Republic. That's my country of birth. But yeah, so settings. I'm just conscious about time, but so are you talking about different settings of on the slicer?
So with the G-code file, the encodings you can, that the printer reads is either ASCII or binary, if I'm correct. So which encoding would be best for quality?
It depends. I hate to say that, like it depends. But you know, it depends also like which printer at the end of the day you use. I'm just not too sure if I understand exactly the question. I think Justin, you coming in, maybe
Yes.
you want to answer. I can't hear properly.
Yeah, so Nathan, good evening, everyone. So the encoding you use,
Encoding.
if it doesn't have any compression and there's no lostness, it doesn't matter what you use. Because it'll be interpreted at the printer the same way as it would either way.
Thank you, Justin.
Yeah, thank you, Justin. That's what I meant by it depends. Whoever prefers, some people prefer Cura, some people, you know, refer to Prusa, whatever your end code is. Get the right quality, slicing, slow it down. Yeah, I always say, there's so many different aspects of slicing on its own. We can have a different lesson for that.
The biggest thing is it doesn't matter what you've got, and you've got lots of options. Try all of them, see what works for you.
Yeah, 100%. The settings and the fans, and you know what type of machine you have.
Yeah, you also mentioned the nozzle size for detail as well. So that also helps.
But it's mainly it's really with the slicing. There's a lot like around retractions and like the speed, the travel. Yeah, it's slicing on its own. We can spend 2 hours and more to go through that.
Okay, I think it's coming to the end. I know we're already 16 minutes over time. But there is a question in the chat from Christo Pietra. Any views on clay printers? Is it best to design and build it yourself, or are there affordable clay printers on the market?
So when it comes to those kind of things, I'm a still believer that the market, from a commercial perspective, it's still not there yet. And I don't want to be a naysayer yet, but I really just an honest answer. It's when it comes to these printers. I mean, same thing, you know, it's for example, the food printer that we were talking about earlier. It's just from a commercial point of view, what you will be better off is to work when it comes to any of these materials like clay, you use the molds to 3D print the mold. And then you actually keep on using your, you know, whether it's clay or, you know, we've been using, for example, recycled plastics once, you know, you get them all. So when it comes to the product and the end user product, like clay printers and so forth, it's quite expensive to get to that. So I would suggest rather start with printing the mold. And then using, you know, go with when it comes to clay, typically then for the mold, you do need, you know, your kind of resin printers. They last in terms of temperature and etc. But I don't want to get into that too lengthy now, but just a quick kind of answer to that. It's still commercially quite expensive to use clay printers, if that helps to answer your question.
Thank you, Pietra. And yes, I think we might need to have a follow-up on the details of leveling beds and what sticks and what doesn't stick and how to all of that stuff going. But I think you've given us a very good comprehensive overview on 3D printing this evening, and you've also opened up the offer for people to contact you for guidance. So thank you very much for that, Pietra. Is there any last questions before we say a very big thank you? No? Well, then I'd like to say, Pietra, a very big thank you for your time this evening, for preparing a presentation for us hobbyists and makers. And hopefully it will encourage us to get one of those 3D printers. And yes, I took away the advice, spend a little bit more and you won't be quite as frustrated. It'll give you option. So thank you very much, Pietra, for your time this evening and for coming to speak with us on 3D printing, and to everybody who has participated this evening.
Thank you very much, everyone. I appreciate your time. Thank you. Thank you, Keith. Lovely being here. Appreciate it. Keep well.
Thank you very much, Peter.
Bye.
Good night,
Thank you very much. Good night.